Okay, we're going on now to topic 7.6, which is solving radical equations. Now, so far we were dealing with expressions because in our examples there were no equal signs. But here there are equal signs. They are equations, and they generally contain radical signs. Here this one doesn't, but it's a little special case there. Okay, so what is the overall general technique for getting rid of the radical signs? Because we want to find out what x is. And this comes up from what we've done, that if we raise, this is our index power is 2, if we raise this to the second power, or whatever the index number is, then this just becomes the radicand. But if we do something to this side, we must do it to this side as well. In fact, let's go through it and get rid of the radical signs. First thing first, though, is we have to isolate the radical. So we're going to transpose that. On this side, this becomes a positive 3. So we now have this as 10. And we're going to square this then. That just becomes the radicand. And we had to square this, and that becomes 100. So we brought the negative 3 over, became a positive 3. This became a 10. And then we're going to square both sides. Whenever we raise something to the power of its index number, it just becomes the radicand. So that's our equation. Same thing here. We're going to bring the negative 2 over. That will become a positive 2. So this will become a 3. And we're going to square the 3. That gives me a 9. And when we square this, it just becomes the radicand. And now we can start cutting corners a little bit. We don't have to show everything. We're going to square this. Well, first we're going to bring that over. That goes over as a negative 6. This just becomes a 4. We're going to square the 4 and get 16. And when we square this, it just becomes the radicand. Now here's a little twist. Here the index number is 3. So we're going to raise that to the index number. Oh, that's a funny kind of 3 there. And we do it to that side as well. This then just becomes the radicand. Same thing here. We're going to raise this to the 4th. Raise this to the 4th. This just becomes the radicand. Number 9 is a little tricky because we have to square this side. Square that side. So this becomes a squared. This is 7 squared is 49. and then a times a, or just the radicand a. So here we now have something a little different. We have a quadratic. We'll get to that. Now here again, we want to isolate the radical. Well, there's no radical. In a sense, can you see this is the square root of x here? The 1/2 power is the square root of x. Okay, we're going to get rid of this by bringing it over to the other side. This becomes a plus 10 there. So we now get 12. And we have 6x to the 1/2 power equals 12. We're going to divide both sides by 6. And then we get x to the 1/2 power equals 2. And then now watch what we're going to do. What do we have to multiply this by to make it just plain x? Well, we have to square it. Well, we're going to square the 2, and we get x equals 4. Well, I worked all of that one out. This one is done the very same way. We're going to raise this to the 3rd power, raise this to the 3rd power, and we get x equals negative 1,000. So we solved those. But let's go back. Let's change colors, make this colorful. So here we're going to add 7 to both sides, and we get 3x equals 32. And then we're going to divide both sides by 3, and we get x equals 32/3. And then here we're going to divide both sides by 6, and we get x equals 50/3. Here we're going to add 8 to both sides, so we get n equals 17. Here we're going to subtract 2 from both sides, and we get z equals 14. Here we're going to subtract 3 from both sides, and we get t equals 61. Here we're going to add 9 to both sides, and we get y equals 25. All right, number 9 is sort of the tricky one. We did all of it, and now we have a quadratic equation. Well, how do we solve quadratic equations? Well, we put them in standard form. And now we factor. And then we equate each of these to 0. A equals 0, A minus 49 equals 0. So here our solution set will be 0 and 49. So actually not too difficult. And you know, the key to this is getting rid of the radical. And that's what we showed you with all of these, so that we turn them then into regular equations. The red and the green make this board look a little Christmassy. All right. Right, in this next part, as we look at it, again, can you see here that z to the 1/3 is the same as the third root of z? This is its radical form, and this is its fractional exponent form. But again, there is a protocol, so let's go through it. You want to isolate the z, so you're going to add 1 to both sides. So this then becomes 4, and you get then z to the 1/3 that you'll raise to the third power. And then this just becomes z equals 64. Now keep in mind, you could have had this as the square root of this. Watch this though. Here we're saying the square root of something is equal to a -6. Is it possible that the square root of something can equal a -6? And the answer is no. So for number 13 is the kind of a unique case where there is no solution. All right, in this case, again, you have to be a little careful. It is an even index number, but when you bring the -7 to the other side, this then becomes a 2. -7 plus 7 gives you a +2, and you can have that. And you're going to raise this to the 4th power. You just get the radicand. And now you're going to raise this 2 to the 4th power. And then you solve it. Again, I could solve it, but that's a skill you ought to have. Here we're going to work on solving radical equations. And again, this is to the 3rd power. This becomes t plus 4 equals 3 to the 3rd power is 27. Here we're going to subtract 5 from both sides. So this then will become a 3. And we're going to cube that. And as we cube this, it just becomes the radicand. 4y minus 1 equals 27. And I think these are equations you can do. Now in something like this, where you have a radical equals a radical, and they're both with the index number 2, you're just going to square this side to get its radicand. And you square this side to get its radicand. And there's the equation. Number 18 is a little tricky, because if we raise both of these to the 4th power, the 2 now becomes a 16 times this, which is just that, and then this just becomes 8, raising this to the 4th power. For number 19, that's a little tricky too. So again, we want to isolate the radical. So we take our 7, bring it over to the other side, where it becomes a negative 7. So our equation now is, and I'll do this one for you, 2 the square root of x plus 1 equals x minus 7. Ah, that was sort of easy. But what do you do next? Well, we need to square this side, and we need to square that side. So then this becomes 4 x plus 1, because we're squaring the 4. When we square this, it just becomes the radicand. And now we're going to use that special technique to square a binomial. We're going to use that in the next chapter. So that's x squared minus 14x plus 49. Then this is going to become 4x plus 4 equals x squared minus 14x plus 49. Well, we have a quadratic equation. And we need to integrate this into this side, put it in standard form. So this is going to give us x squared. I'm going to subtract this from both sides. This gives me a negative 18x. I'm going to subtract this from both sides. That's going to give me a 45. And now what do I do? Well, I have to factor this. And we're looking for factors of 45 that add up to 18. Well, how about 3 times 15? And they're both negative. So our answers are a 3 and a 15. And let's just check that here. That was number 19. Now an interesting thing happens there. If we put the 3 into this, it's saying that the 3 doesn't work. The only one that works here, it's one of those real tricky things, will be the 15. And to show you what kind of professor I am, I have done the proof of number 19. If I put the 3 in there, in my original formula, I get then 3 plus 1 is 4. The square root of 4 is 2. 2 times 2 is 4. 4 plus 7 is 11, and that does not equal 3. And if I put the 15 in there, 15 plus 1 is 16. The square root of 16 is 4. 2 times 4 is 8. 7 plus 8 is 15. And this one checks. This one doesn't. This is what we call an extraneous root. That is, in the process of squaring things sometimes, we generate answers that do not satisfy the equation. And that's why it's important to check your work. And again, in the old days, I would give people credit if they put both answers. Because look at all that you've done, and you've got this far. And again, if you check your work, you'd eliminate the 3. But if you didn't check your work, you'd end up with an extraneous answer, which is not valid. But again, you've done lots of work. I didn't do all the other solutions. The answers are in the back of your chapter work. And what we're doing here is showing you how to solve radical equations by getting rid of the radicals, and whether they're in this form or this form, it's pretty much the same. You raise it to the index number power. That eliminates it, and we'll see if we're going to do some more. On these next two, example 20 and 22, I worked it out, so it wouldn't take all the time to do it, but I will explain it step by step. And the way it worked was, in black for number 20 is our original equation. And we had a radical on this side, and a radical and a constant on that side. So again, the technique is the same. You square one side, square the other. So when I squared this, I just got the radicand. And then here you had to use that special technique of squaring a binomial. So we squared the first term. That gave us a 1. We multiplied this term by this term. That gave us a 1 times this radical, and we doubled it. That's where I got the 2. So the middle term, this multiplied double, is this. Then we squared the last term, just became the radicand. Now, then we had to collect like terms, because we want to isolate the radical on one side. So I have a 1 and a -3. That was a -2 that I then added to this one over here. On this side it became a +2, so this became a 3. So a -2 brought to this side, added to the 1, was a +2, and a 1 is a 3. And then I subtracted 4x from this side and this side, and that gave me the x. So I now have a binomial, but I still have a radical here. So I squared this side, and I squared this side. Now when I square this side, I square the 2, that gives me a 4, and this comes out of the radical sign as the radicand, and I just had to multiply this through, and I got this. And I squared that binomial, square this, multiplied this, double it, square that, and I got this. Again, I have a quadratic, so I need to integrate this onto this side, so it's equal to 0. I'm putting it in standard form. So I subtract 16x from both sides, and I get a -10x. I add 12 to both sides, and I get a 21. It's now in standard form of the quadratic equation. I then have to factor it, because that's the only way we know how to solve quadratic equations. These are the factors. And I FOILed it to check that it worked. Then I equated each of my factors to 0, and I get 3 and 7. Now, interestingly, as I did this, the first time, I'll be honest, I had a little error in there. And it didn't check out, so I found the error. I won't tell you where it was, but there was a little error in there. Again, the technique is correct, but just making a little error somewhere can really mess you up. Okay, so number 22. Again, it looks rather complex, and it is complex. So the rule is you have two radicals on one side, you have to isolate one of the radicals. So I chose to take this negative radical, bring it to the other side as a positive. So now I have one radical and one radical. I squared both sides. So here I get 2 squared is 4. This just becomes itself, and that's what I have here. Now as I squared this binomial, I squared my first term. I get that. I multiply these two terms together, double it. I get that. Then I square what's under the radical sign, and it just becomes the radicand. And then I group like terms. And that's what I did here. So I got rid of the parenthesis, got that. I got my -3 and a +1, left me with a -2. I just brought this over here so I could see it better. And then now I took these terms, transposed them over to this side. So to get rid of a +4y, I have to subtract 4y. Subtract 4y from that gives me my 8y. I have to add 2 to this. I added 2 to this. I got that. So now I have what I have in red is what I've done. Now as I looked at that, I saw this was an 8, this was a 6, this was a 2. I can make this a little smaller by factoring out or dividing out a 2. So then this became a 4y, this became a 3, and this just became a 1. So what I had in black now is what I get as the results when I divide by 2. And these are smaller numbers. But I still have a radical. So again, I'm going to square this side, square the radical. When I do that, I just get the radicand. But I have to do the special technique of squaring a binomial. I squared my first term, multiplied these two together, got a -12y, doubled it, got a -24y, squared the -3, I get a +9, and then this just becomes the radicand. Now I want to integrate this over to this side so it's in standard form. So I'm going to subtract 4y from both sides, right here. And when I do that, I get a -28y. So 4y, a -4y to make this a 0, a -4y added to this gives me my -28y. I'm going to add 3, I get a 12. Okay, so I changed color, we're in purple now. Now, I notice 16, 28, 12. I could take out a 2, but I could take out a 4. So that's what I did. I took a 4 out of every term, and I ended up with 4y squared minus 7y plus 3 equals 0. The only way we can solve that quadratic equation is by factoring. So here are the factors. And then I equated each of these factors to 0, and I get x is, or y is 3/4, y is a +1. And that was the answer. I didn't make any errors on this one. I got it the first shot. But look How long do you think it would take to do that? And I mean, you're thinking of what steps to use, what technique. You got to be careful about signs. You're squaring binomials, you're simplifying, you're doing all kinds of stuff there. So these are some major skills from topic 7.6. And that's where we'll complete this lesson.